With major historic inventions, there often follows a bunch of spin-off support businesses, like when the car came about. That led to gas stations, motels, drive-through food places so French fries could hide under the car seat. It was the same thing with airplanes. Couldn't land them on roads, and of course travelers in airports needed mani-pedis and massages. Plus, at some point they realized that stoplights wouldn't work at 10,000 feet. And it's very possible that I have those a little out of chronological order. Before these air traffic control towers, we had these.
We have the glasses on you. Your main gear still appears to be up.
Pilots with radios and men on the ground with light beams.
It was more or less the Wild West in the skies before we had an air traffic control system. Really, until the mid-1930s or so, there wasn't enough air traffic to merit such a system.
So how did we evolve into what's now known as air traffic management? We called on Mr. Matt Anderson, curator of transportation at the Henry Ford, to break it down.
The first real innovation is at Cleveland's airport in 1930 when they built an air traffic tower so somebody can be up there watching planes and they could communicate by radio with the pilots and kind of suggest where and when they should land.
So you get your first air traffic control tower in Cleveland, and do they start sprouting all over the place?
It's such a great idea. Other airports copy that idea almost immediately.
But still no system in place to control the traffic in the skies. The air traffic control towers evolve because they're now being used to transmit what?
The big breakthrough comes with the introduction of radar, which is experimented with in the 1930s, but it really comes of age during World War II and refined in Great Britain where they use it for defensive purposes.
Here's how radar works. It transmits radio waves through an antenna in a particular direction. That signal bounces off a receiver, sending a signal back. The length of time it takes for that process determines an aircraft's location and speed. But it can't tell you the altitude of a plane, so controllers would still have to communicate via radio with pilots for that information.
So you had to keep track separately of the airplane flight number and the altitude of the airplane. You had to write them down on these little plastic shrimp boats, they called them, little markers that you would set on the radar screen and then move along to follow that blip.
What's the next step in the evolution then?
The next big breakthrough is this piece of equipment right here, which is a radar detector scope designed in the 1960s. And this is capable of simultaneously displaying the blip as well as the airplane number and the altitude. So there's no need for those little plastic models anymore. It's all automatically done.
So take me through how this works.
So this would be wired into the terminal in the tower, which would be connected to a radar antenna, which spins around and collects all the information from the air. But this is sort of where the rubber meets the road. This is where the air traffic controller would sit. The screen would light up, and you would see a radar beam sweeping around. And every few seconds, it would update information with little blips showing you where airplanes were located.
Today, air traffic is managed through GPS technology, but it all began with the radar. A person manning a radar scope is kind of like an orchestra conductor.
That's a great way to put it. You've got a lot of different airplanes in the air. You have to keep track of all of them, where they are, and make sure that they all move without interfering with one another.
Are in harmony.
Exactly.
Right?
That's right.